Hello everyone. For the past few days, we were discussing on how diseases and climate change are related. The very first day we have discussed about how it is related, and we have given a brief introduction. The second day we have discussed climate change and infectious disease. Third day we have discussed on impact on allergic diseases. Yesterday we have talked about exacerbation on human spread of disease. Today, myself, Mr. Jesudas Nadupuri, along with we have Dr. Indike Gopi and Dr. Dahi Suleiman. Today, we are going to discuss on influence of zoonotic carriers and climate change. Zoonoses are those diseases and infections which are naturally transmitted between vertebrate animals and man. Zoonoses include only those infections where there is either a proof or a strong circumstantial evidence for a transmission between animals and man. Till today, zoonosis an international problem. Historically, zoonosis disease had a tremendous impact on the evolution of man, especially those cultures and societies that are domesticated and breed animals for food and clothing. Zoonoses are among the most frequent and dreaded risk to which mankind is exposed. Zoonoses occur throughout the world, transcending the natural boundaries. Their important effect on global economy and health is well known, extending from an international movement of animals and importation of diseases to bans on importation of all animal products and restrictions on other international trade practices. How zoonotic diseases are being transmitted? We have different modes of transmission. The very first one is airborne. Airborne transmission refers to a situations where droplet nuclei resides from evaporated droplets or a dust particles containing microorganisms can remain suspended in the air for very long periods of time. These organisms must be capable of surviving for longer periods of time outside the body and must be resistant to drying. Airborne transmission allows organisms to enter the upper and lower respiratory tracts. The second one, vector-borne, that are transmitted from infected agents from animals. That are animals that are capable of transmitting diseases. Example, vectors like flies, mites, fleas, and dogs. The most common vector for disease is mosquito. The third one is direct contact with animals. Coming to the contact with areas where animals live with saliva, blood, urine, mucus feces, or other body fluids of an infected animal. Example includes petting or touching animals or bites, scratches. And the next is close proximity to animals, which is also called as indirect close contact. Coming to coming into contact with areas where animals live or roam. or objects or surfaces that have been contaminated with germs. Example include aquarium tank water, pet habitats, chicken coops, plants and soil, as well as pet food and water dishes. The last one is foodborne. Foodborne diseases occur majorly by eating or drinking something which is unsafe, such as unpasteurized or a raw milk, uncooked meat or eggs, or raw fruits and vegetables that are contaminated with feces from an infected animal. Contaminated food can cause illness in people and animals, including pets. In this picture, we can see the facts of zoonotic diseases. Over 200 zoonotic diseases are caused by bacteria, parasites, fungi, or proins. 13 out of 20 zoonoses caused about 2.4 billion deaths globally. About 3 out of 5 new emerging diseases each year are zoonotic. According to WHO reports, 75% of new diseases discovered in the last decade are zoonotic. About 61% of all human diseases are zoonotic in origin. We can see the SARS more or less similar to COVID-19. Outbreaks can be traced to horsehoe bats of China in 2003. About 2.2 million deaths and 2.4 billion illness per year are caused by zoonotic diseases. Zoonosis, an emerging problem. Over the last 2 decades, there has been considerable change in importance of certain zoonotic diseases in many parts of the world, resulting from ecological changes such as urbanization, industrialization, and diminishing proportion of persons working in so-called primary sector. Among those zoonoses recognized today as particularly important are anthrax, plague, brucellosis, bovine tuberculosis, etc. are common. Classification. When we come to the classification, we have different mode of transmission. The very first one we can talk about according to the etiological agent. That is bacterial zoonosis, example like anthrax, brucellosis, plague, leptospirosis, etc. Then viral zoonosis, example like rabies, arbovirus infection, etc. Rickettsial zoonosis, example tick typhus, scurf typhus, Q fever. Protozoal zoonosis, example like toxoplasmosis, trypanosomiasis, leishmaniasis. Helminthic zoonosis, examples like teniasis, fungal zoonosis, example deep mycosis and superficial dermatophytes. And the last one is ectoparasites, example like scabies, myiasis. The very next classification according to mode of transmission. So we have different kinds of transmission modes, that is direct zoonosis. These are transmitted from infected vertebrate host to a susceptible host, that is humans, by direct contact or by contact with fomite or by mechanical vector. The agent itself undergoes a little or no propagative or development changes during transmission. Example rabies, brucellosis, etc. The next is cyclozoonosis. These require more than one vertebrate host species in order to transmit, but no invertebrate host for the completion of life cycle of an agent. Example, teniasis. The next is metazoonosis. These are transmitted biologically by invertebrate vectors in which the agent multiplies and or develops, and there is always an extrinsic incubation period before transmission of the disease to another vertebrate host. Example, plague. The next is saprozoonosis. These require vertebrate host and a non-animal developmental site like soil, plant material, etc. for the development of infectious agent. Example, cryptococcosis, zygomycosis. The next classification is according to the reservoir host. Anthropozoonosis, infectious transmitted to humans from lower vertebrate animals, which is called as anthropozoonosis. Example like rabies, plague, and Q fever. Zoonoanthroposis, that is infectious transmitted from humans to lower vertebrate animals. Example, diphtheria, human tuberculosis in cattle and parrots. The next is amphizoonosis, that is infectious maintained in both humans and lower vertebrate animals and transmitted in either direction. Example like staphylococcus. Factors influencing prevalence of zoonosis. So there are multiple factors that are influencing prevalence of zoonosis, such as ecological changes in man's environment. With the expansion of human population, man is forced to exploit the virgin territories and natural resources like harnessing the power of rivers, constructing roads and pipelines through virgin or thinly populated areas, clearing, irrigating, cultivating new land, deforestation. Handling animal byproducts and waste, that is occupational hazards. There is significantly higher attack rates in workers during the course of their occupation than the rest of the population. Example, anthrax is carpet weavers, live stock raisers, workers with animal hair, that is textile industry, fish merchants, and then creeping eruptions in plumbers, etc. Other examples of zoonoses are occupational hazards are Q fever in aberrator and rendering plant workers, jungle yellow fever, and tick-borne diseases in woodcutters. Increased movement of man, that is humans, land development, engineering project work, pilgrimages, tourism, etc., expose the people to contaminated food and water, leading to diseases like amoebiasis, salmonellosis, shigellosis, etc. Increased trade in animal products. Countries which import hides, wools, bone meal, meat, etc. from an area where some of the zoonoses are endemic are likely to introduce the disease into their territories. Example, foot and mouth disease, anthrax, Newcastle disease, etc. Increased density of animal population. Animals may carry potential risk of increased frequency of zoonotic agents in humans. Example, tuberculosis, brucellosis, etc. Similarly, transportation of virus infected mosquitoes. Aircraft, ship, train, motor, and other vehicles bring the virus into a new area through transportation. Cultural anthropological norms. In this regard, we can see example in Kenya, people allow the dogs and hyenas to eat human dead bodies infected with Hyderabad. This helped to perpetuate the transmission cycle of disease. Zoonoses is till today as a public health problem. We have number of zoonotic diseases. We can see plague has killed nearly about 120 lakh people since 1898. Rabies continues to be a serious health problem in the country. Approximately 20,000 deaths due to rabies are estimated occur every year within, while more than 17 lakh persons bited by suspected rabbit animals. Typhus killed many people during World War I. Brucellosis alone is estimated to cause animal loss of approximately 300 lakh man days in addition to an annual income loss of rupees 2,400 lakh throughout the brucellosis in cattle and buffaloes. Japanese encephalitis is another emerging zoonotic disease in India, causing several outbreaks and considerable morbidity and mortality. Kala Azar, although proved zoonotic all over the world, continues to be a non-zoonotic in India in spite of epidemiological evidence suggesting it to be zoonotic. Cutaneous leishmaniasis is which either to be considered an anthropognosis in India has been proved to be zoonosis recently with the Indian desert as an animal reservoir. It is also surprising that in India, where approximately 80% of population lives in rural areas in close contact with a large domestic animal population, that is poultry and other wild and semi-wild animals. SARS, MERS, these more or less similar to COVID-19 which we are currently facing. SARS, severe acute respiratory syndrome, is viral respiratory illness caused by coronavirus called SARS associated coronavirus. SARS was the first reported in Asia in February 2003. Over next few months, the illness spread more than 2 dozen countries. According to WHO, a total of 8,998 people worldwide became sick with SARS during 2003 outbreak. Of these, 774 were dead. The main way that SARS seems to be spread is by close person-to-person contact. The virus that causes SARS is thought to be transmitted most rapidly by respiratory droplets, similar to COVID-19, produced when an infected person coughs or sneezes. Droplet spread can happen when droplets from cough or sneeze of an infected person are propelled in short distance, that is generally up to 3 feet, through air or deposited on the mucous membrane of mouth, nose, or eyes of a person who is nearby. In similar way to COVID-19. And MERS is also similar to SARS. Here the host is camel is a carrier. The next Ebola. Ebola virus disease, formerly known as Ebola hemorrhagic fever, is rare but severe, often fatal illness in humans. The virus is transmitted to people from wild animals and spread in human population throughout human-to-human transmission. About 50% case fatality rate and varied from 25% to 90% in the past outbreaks. It is thought that bats are natural Ebola virus host. Ebola is introduced into human population through close contact with blood, secretions, organs, or other bodily fluids of infected animals such as fruit bats, chimpanzees, gorillas, monkeys found ill or dead or in the rainforest. Ebola then spread through human to human transmission via direct contact through broken skin or mucous membrane that animals which are infected. Nipah. Human infections range from asymptomatic infection to acute respiratory infection and fatal encephalitis. Infected people initially develop symptoms including fever, headache, vomiting, sore throat. This can be followed by dizziness, drowsiness, altered consciousness, and neurological signs that indicate acute encephalitis. Some people can also experience atypical pneumonia and severe respiratory problems, including acute respiratory distress. Encephalitis and seizures occur in severe cases, progressing to coma within 24 to 48 days. So, how we are going to prevent this zoonotic disease transmission? The first and primary thing is to have a proper personal hygiene. Washing hands before and after animal handling, and by not eating or drinking in the animal housing areas, by wearing coveralls, farm specific clothing, or laboratory coats when handling animals. Avoid handling sick animals or animals with lesions unless gloved. Wear a mask if you are allergic to animal hair or dander, or if feed or bedding dust is present. If you are sick, do not enter agriculture animal facilities. You are more susceptible to other infective agents and you may transfer pathogen to the animals. Routinely wear gloves when cleaning the animal area. Note progression of any illness. Report illness to your concerned doctor or supervisor of the animal. Inform physician of your animal related activities. The second is how we are protecting ourselves or having a personal hygiene. We should even take care of our environmental maintenance. By keeping animal housing areas well organized and clean, avoiding urine and fecal buildup. Dry feces result in fecal dust which may be inhaled. Clean rooms have a lower likelihood of horizontal or zoonotic transfer. Proper ventilation protects the animal and workers. Clean feed and bedding from floors. Litter attracts vermin which may introduce zoonotic disease into facility. Third is herd or flock maintenance. By observing animals for health status on daily basis, report sick or dead animals, note health problems such as diarrhea, difficulty breathing, depressed or immobilization of animals. Take extra caution in cleaning the areas around ill animals and do not spread possible pathogens to other healthy animals. Isolate affected animals as appropriate. Record history or progression of animal disease. So, by this, we end the episodes of climate change and infectious diseases. I hope you have gained an informative knowledge. We thank you for spending your valuable time in watching the videos. Thank you.